Section 11.7, we're going to look at geometric probability, and this is going to relate very closely with the areas that we've talked about so far in this chapter. So, first of all, probability in general is the likelihood that an event will occur. Okay, so what is the probability that you'll win the lottery? Okay, well, obviously not very good, otherwise everybody would play it. Well, everybody does play it, and most people don't win. Very few people win the lottery. So, now when we look at geometric probability, okay, we're going to look at a ratio that involves a geometric measure, usually length and or area. Mainly we're going to look at area problems, but if you look at this first highlighted section here, it says the probability in length. It says let AB be a segment. In other words, here's your whole entire segment right here, and you have C and D on it. Okay, if a point K is on AB, or on AB is chosen at random, then the probability that is on CD is the ratio of the length of CD to the length of AB. So in other words, the probability that the point is on CD is however long CD is over however long AB is. Okay, because again, there are so many points here along this segment. Okay, and what they're saying is, what is the probability that if you just kind of close your eyes and randomly choose this point here, what's the probability that that point will lie on this portion of the segment? Okay, and so really you're trying to figure out what percent is this guy of the entire thing. Okay, and that's really what you're kind of asking yourself. Alright, so if we look at this, it says find the probability that a point K selected randomly on AE is on the given segment. Express your answer as a fraction, decimal, and percent. Okay, so in other words, if I look at AC, okay, I'm looking at this entire length. The entire length here is obviously 8 units. The length of AC is 4. So the probability they'll lie on AC is 4 over 8, which is 1/2. As a decimal, that's 0.5. And as a percent, that's 50%. Okay. What's the probability that lies on BC? Well, BC is going from 1 to 4. That's 3 units long out of 8. Okay, so 3 over 8 cannot be reduced down. But if I look at the decimal, let's see here. I gotta, again, 3 over 8 is 0.375 as a decimal. And as a percent, that is 37.5%. So there's a 35%, 37.5% likelihood that you'll lie on BC. Okay, CD here. CD is 2 units long, so 2 over 8, which is 1 over 4, which is 0.25, and that's 25%. And finally, AD is from 0 to 6, so AD is 6 over 8, which is 3 over 4. That's 0.75, which is 75%. Okay, so I think this is a pretty straightforward idea. It's the piece over the whole thing. What piece are you trying to hit? And then put that over the entire thing. Again, this is kind of where we're going to live here in this section. So when it comes to probability and area, it's very simple. Okay, you want the probability, it's the ratio of the areas. So if you want to know the probability of landing in this region right here, then you're going to do area of M over area of J. In other words, the area of the little piece over the area of the entire shape that you're choosing from. Okay, so if I look at this first example here, example 2, it says a golf ball is hit and it stops on a green. A prize is won if it stops in the painted circle. The diameters of the green and the circle are shown at the right. If the ball is equally likely to stop on any point on the green, what is the probability that the prize is won? So in other words, we're trying to land it here, and this is the entire spot that we're hitting. Okay, and so again, the idea here is the area of the small circle over the area of the entire thing, which is, we'll call it the big circle. Well, the area of the small guy, the diameter is 15, so again, it's circle, so it's pi r squared. The radius there is 7.5. And the area of the entire thing is going to be pi. Half of 75 is, 37.5 squared. Okay, and so now I'm just looking at this ratio. One thing you'll notice here, the pi's are just going to cancel. So really the only ratio we have to look at is 7.5 squared. So we have 7.5 squared over 37.5 squared. I screwed that up. Let's see here. 7.5 squared over 3.75 squared equals Alright, I don't know why my calculator's malfunctioning here. Or actually, it's not the calculator, it's me. 7.5 squared over 37.5 squared equals 0.04. Here we go. So 0.04, okay, and again, 0.04, that's not really very good. So the percentage-wise, you have a 4% chance. In other words, 4 out of 100 balls are going to land and win. Okay, and so that's what we're looking at here when we talk about geometric probability. This question is kind of goofy because really there's no area formulas involved here. It says what is the probability that a deer will be on grass? Well, first of all, I've never seen a deer swim. Okay, I know they do, I know they can, but it's not like deer just kind of jump into a lake for a random afternoon swim. Usually, if they swim, it's probably because they're trying to get across the river or something to get to a food source. But anyway, forget that this is kind of a goofy question. Okay. A better question probably would have been a goose or a duck or something that actually hangs out in the water. But anyway, so what is the probability that it will be on the grass? Well, here's the deal. You have to kind of estimate the entire region. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. There are 44 full boxes plus, I would think that these two here kind of make up one full one, okay? And then I would also say that these two guys kind of make up another full one, and these two make up a third full one. So I would say that the entire area is 47. Okay, and the grass goes up to here. Okay, and so if you look at that, the grass is going to be 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8. So 4 by 8 is 32. So the probability is going to be 32 out of 47. And so percentage-wise, 32 over 47 is there's a 68% chance that this deer is going to be hanging out on the grass. Okay. Kind of a goofy question. That's more just kind of understanding what the question's asking and knowing how to find an area given a grid. All right, so we will look at plenty more examples tomorrow in class involving probabilities in areas. So you're just going to have to kind of refine those formulas that we talked about early in this chapter and bring them back.